All right, I'm going to talk about Kepler's third law, which states the ratio of the squares of the periods t of any two planets revolving about the sun is equal to the ratio of the cubes of their mean distances r from the sun. Now, one thing to keep in mind that if we talk about the mean distances, that means we're actually, discussing an average. Planets do not technically move in circles; they move in ellipses, which means the point at which they object around or orbit around is not located in the dead middle of the circle. It's off to the side. Okay, if we were to draw, say, a little picture of an ellipse might look a little bit more like this, where maybe this is the center of rotation, so that this radius and this radius are different. So you'd have to take the average of those two. Okay, now this is fairly elliptical. This is actually pretty darn elliptical. Most planets are fairly close to circular, but not all. Okay, so there's a fairly easy derivation for this, and I want to draw a picture first. Let's say this is the sun, okay, and here's the Earth. Okay, the only force that's keeping us bound to the sun is gravity. Okay, nothing else affecting us. Okay, so one thing that I know is that the f of g in this case, since the Earth is orbiting about the sun like this, the center of the circle that it's orbiting is this direction. Therefore, f of g is the centripetal force. So using that knowledge, okay, we're going to write that the f of g is equal to the f of c. Okay, so I'm going to substitute in Newton's universal law of gravitation. So g, mass of the sun, mass of the Earth, over the radius squared would be equal to the mass of the Earth times the velocity squared over the radius. Okay, now, before, in earlier classes that we've had, I've talked about the velocity of the object in circular motion being 2 pi r over the period. So what I'm going to do is I'm going to substitute this into this equation. Okay, so I would get g ms me over r squared equals me. I'll go ahead and put the r on the bottom. So now I got to square all this stuff. So we get 4. We get pi squared, radius squared, and t squared. Okay. Now this radius and one of those goes away, and I see that the mass of the Earth is on both sides, so that can also go away. And now this really just turns into rearranging. Okay, so I'm going to bring the t squared over. Okay, I'm going to bring this r down. So as of right now, if you remember what I said about Kepler's third law, let's go back to it here. It says the ratio of the squares of the period of any two planets revolving about the sun is equal to the ratio of the cubes of their mean distances from the sun. Now you already notice that I've got t squared and r cubed. That's good. Okay, so then the rest of this, since I'm going to cross some of this stuff off. So that's gone, that's gone. Alright, I've still got the 4 pi squared, and I've got g and the mass of the sun. Okay, now this is more oftentimes written in this form. Okay, but it's essentially the same thing. Okay, now I did this in terms of the Earth and the sun. You could do it really in terms of anything. thing. Okay. Now, because that is true, this could be the period of the Earth and the radius between the Earth and the Sun. But if this is a constant value for any object orbiting the Sun. So technically, if this was, say, just one object, period of 1 and the radius of 1 cubed, and I had another object that was that had the same relationship, period 2 over r2 cubed. Oops, sorry, I missed some of this stuff. Okay. If this is true, if these two objects are true and they share this, if they both equal that value, then I can say that t1 squared over r1 cubed equals t2 squared over r2 cubed. Okay? And oftentimes, Kepler's third law could be written like this, or it could be written like this, or you might see it as t1 squared and t2 squared equals r1 cubed and r2 cubed, or they might actually take those out, so the t1 over t2 and this whole thing squared equal to r1 and r2 cubed. Okay, these are all options for Kepler's third law. But mostly what you should remember is that the period squared is proportional to the radius cubed. Now, one other thing that I think should be fairly important for you problem-solving wise, if you're given 3 of the 4, you got to get rid of these exponents on either side. So if I wanted to solve for, say, a radius, I'd have to get rid of the cubed. Then you would end up with t1 over t2, and that would be to the 2/3 power equal to r1 over r2. And then the reverse would be true if, say, I wanted one of the periods here. Then that would be r1, r2 to the 3/2. So I'll write it again. t1 over t2 would be r1 over r2 to the 3/2. So those are all common variations of Newton's third law. Okay.